Hello friends, myself Dr. Rakesh Vats, Professor and Head Department of Media Engineering at NITA Chandigarh. It gives me a great pleasure to welcome you to the very first session of our MOOC on climate change and disaster risk management. Over the next few weeks, friends, we will explore how the climate is changing, why it matters, and what can we do to build a safer and more sustainable world. But before we talk about solutions or disaster risks, we must first understand what exactly is the climate change. That's the focus of today's session, that is, understanding climate change. So let's begin first with the basics. You often hear the words weather and climate. Many a times these are used interchangeably. Are these the same? No, they are not the same. On one hand, weather is what you experience today. It might be sunny, raining, or windy outside. On the other, climate is the average of those weather patterns over a long period of time, maybe 30 years or more. Now, when this long-term pattern begins to change significantly, we call it climate change. Unfortunately, that's exactly what's happening in our planet right now. But why it is happening? Climate change can occur naturally, for example, through volcanic eruptions, variations in solar radiation, or shifts in Earth's orbit. These natural cycles have always existed. However, in the last century, something new has happened. Human beings, through rapid industrialization, deforestation, and our hunger for energy, have begun to alter the planet's delicate balance. This human-driven change is called anthropogenic climate change. Let's understand this better. Imagine Earth as a giant greenhouse. The sun's energy enters, warms the surface, and some of that heat radiates back into the space. Certain gases, known as greenhouse gases, in the atmosphere trap part of this heat, keeping our planet comfortably warm, just like glass panels trapping heat inside a greenhouse. This is perfectly natural and necessary for life. Without it, Earth would be a frozen world. But here is the issue of our concern. Human activities have dramatically engaged these greenhouse gases, thickening that invisible heat blanket. This extra trapping of heat is what we call the enhanced greenhouse effect, and that's what leads to global warming. So which gases we are talking about? The major ones are carbon dioxide. This is released when we burn coal, oil, or natural gas. It's the largest contributor to human-caused warming. Then comes methane, produced from agriculture, livestock, and landfills. Although less abundant, it traps heat nearly 30 times more effectively than carbon dioxide. Nitrous oxide, this comes from fertilizers and industrial processes, nearly 300 times more potent than carbon dioxide. Then comes fluorinated gases used in refrigeration and industrial activities. Although these are in tiny amounts, but their warming potential is thousands of times higher than carbon dioxide. And let's not forget the water vapor, which naturally amplifies warming once the planet heats up, a kind of feedback loop that makes the process stronger. Let's bring this closer to our home, the India. In India, we see the impact of these gases every single day, every single year. Our cities are hotter than before. Summers start earlier and last longer. We experience intense floods, prolonged droughts, and forest fires. sometimes all within the same year. The Himalayan glaciers are melting faster, and coastal regions like Mumbai and Chennai facing rising sea levels. Oh, yes, the effects are not distant or theoretical, they are visible, measurable, and affect our daily lives. But what's driving all this? Mainly our dependence on fossil fuels like coal, petroleum, and natural gas. These are needed for electricity, transport, and in running our industry. When we burn these fuels, they release carbon dioxide. Then comes deforestation, which is worsening the problem more. Trees that absorb carbon dioxide are cut down for urbanization and agriculture. So, not only we are emitting carbon, but we are also destroying the natural systems that could have helped absorb it. And to these, the emissions from factories, fertilizers, and waste, and we have created the perfect recipe for global warming. This warming has far-reaching consequences. We are seeing a rise in global average temperatures, but that's just the beginning. Heat waves are becoming more intense. Cities like Delhi, Ahmedabad, Nagpur have touched record-breaking temperatures above 50 degrees Celsius. Glaciers are retreating, oceans are heating and expanding, and sea levels are rising. This means more floods, stronger cyclones, and greater damage to infrastructure, livelihoods, and ecosystems. Agriculture is also under stress. Crops are failing due to erratic rains and extreme heat. With changing weather patterns come new health risks, heat stress, respiratory issues, and the spread of diseases like dengue and malaria. All these are the signs that climate system is changing rapidly and mostly because of us. But how do we measure our contribution to this problem? That brings us to the idea of the carbon footprint. Simply putting, a carbon footprint is the total amount of the greenhouse gases we release through our activities, whether it's driving a car, using electricity, flying, or the food what we eat. At an individual level, it tells us how our lifestyle choices impact the planet. At the national level, it shows which sectors, energy, transport, or industry contribute to the most amount of emissions. For instance, India's per capita emissions are about 2.9 tons per year, much lower than the global average of around 6.6 tons. Yet, because of our population size, we are still amongst the world's top emitters. The good news is that India is taking significant steps to reduce its carbon intensity through renewable energy and electric mobility. Now, the Earth's climate isn't a simple machine. It has internal feedback systems. Some amplify the change and the others slow it down. These are known as climate feedback loops. For example, when Arctic ice melts, it exposes darker ocean surfaces that absorb more sunlight, leading to even faster melting. That's a positive feedback. Similarly, when permafrost thaws, it releases trapped methane, accelerating warming further. On the other hand, increased plant growth due to higher carbon dioxide can significantly offset this by absorbing more carbon. That's a negative feedback. But unfortunately, friends, the positive feedbacks are now dominating, pushing the climate system towards instability. Here in India, we have already witnessed that what we means. Forest fires in Uttarakhand and Himachal Pradesh, glacial bursts in Chamoli, floods in Kerala, all point to an interconnected system that's heating up and reacting in an unpredictable manner. Our country, despite low per capita emissions, stands among the most vulnerable to the climate change. So, as we end today's session, let's reflect on one thought. Climate change is not just an environmental issue, it's a human issue. It affects our health, our economy, our food, and our future generations. Understanding its causes and mechanisms is the first step towards action. In our next session, we will move from this understanding to scientific evidence. We will explore what data from across the globe tells us about how fast our world is warming, what the IPCC reports reveal, and what the trends mean for India. Thank you for joining me in this session. See you in the next session.